In this video, we're going to talk about the user datagram protocol, better known as UDP. So remember, we talked about TCP in the previous video, and we said that it's connection oriented and it's very reliable, and it has retransmissions of data when data isn't received. Well, on the flip side, UDP does not do any of that. UDP is a scaled down economic version of TCP, because when you add all this extra functionality onto a protocol like TCP, well, it requires a lot of resources, and you'll see this in the next video. Now, on the flip side, TCP is reliable, but UDP is not at all. It's connectionless and it's unreliable. And it doesn't do any sort of data retransmission. So it just pretty much sends data and it says, I'm done with it. I did my best effort. I sent the data. Hopefully it gets there. If it doesn't, oh well, there's nothing I can do about it. And you may be thinking, well, what's the purpose of using something like UDP? Don't you want all of your information that's sent across the network to be reliable and to make sure that that data is actually sent? Well, in certain instances, yes, but in others, no, you don't need it at all. In fact, there are specific reasons why you're going to want to use a protocol like UDP where you don't retransmit data, you don't care if a connection is set up or not, and you don't care if it's reliable or not. So let's think about some examples, and I put some on the screen. So for example, some real live time data that's streaming. For example, a phone call, if you're doing a voice over IP. You're going to have some data loss. You might have some of that connection where the audio doesn't come through, but you're still able to understand what the person's saying. And so it makes it a lot more economical for both you in regards to how much data you need to transmit back and forth and how much you need to pay your internet service provider, but it also makes it more economical for them in regards to how much they need to scale up their network to support VoIP. Another example would be video streaming. So for example, live video streaming. We're not talking about YouTube, we're talking about actual maybe connecting to a live video stream. For example, if you're able to find a live video stream of a sporting game or a sporting match, then it's okay if you have a couple of bits of information or a couple of packets of information here and there that don't get through, because for the most part, your system is going to be able to decode what that is. And you may have a little bit of jarbled information here and there, but you're going to be able to watch that live streaming video. And then same thing for audio streams. If you're doing something like listening to a radio station or a podcast that's live over the internet, again, it's okay if we have a little bit of data loss here and there. But in other instances, you want to make sure that data gets there. For example, where you're connecting securely and you're doing some online banking, well, you want to make sure that your data gets there, and if it doesn't, then they respond and they retransmit. So there's other instances where we want it to be secure, we want to have that retransmission, we want it to be reliable, but in instances like this where we're talking about, for example, real-time data, where we're talking about, for example, VoIP, real-time video streams, real-time audio streams, we don't care, and there really is no reason to have retransmission of data because it's live. It is not data that you're going to wait and pause to watch it. If it's live, then the data is already gone and it really doesn't matter. So that is UDP, and those are the instances and why we would use it. Now in the next video, I'm going to do a bit comparison to show you the difference between UDP and TCP, and just to show you how many more resources are required to send TCP over UDP.